Every day, we take little things for granted, like remembering funny conversations or the plot of our favorite movie. But could you imagine being able to remember everything from elementary school, but yet you couldn't remember where you put your keys 5 minutes ago? Sadly, forgetting is the reality facing those who suffer from dementia related diseases. The most common type of dementia is Alzheimer's disease, which accounts for about 60% of the cases. It affects an estimated 4.5 million Americans. As many as 10% of people over the age of 65 are affected, and that statistic rises to 50% over the age of 85. On average, once diagnosed, a patient will live 8 to 10 years, but certain individuals live as many as 20. Not only does Alzheimer's disease affect the sufferer, but because of its intensive care requirements and financial burden, it also impacts those closest to the patient. The estimated care cost for a mild case of Alzheimer's is $18,000 a year, and those costs rise to $36,000 a year if the patient exhibits severe symptoms. As an alternative, nursing homes cost an average of $42,000 each year, and familial caregivers cost businesses upwards of $36.5 billion a year in lost productivity. Although the damage is not visible on the outside, the brain of someone who suffers from Alzheimer's disease shows clear signs. The cortex shrivels up significantly, affecting the areas of the brain involved in thinking, planning, and remembering. A study done at UCSF compared brains of those who are cognitively normal, those who suffer from mild cognitive impairment, and those diagnosed with Alzheimer's disease. Those with mild cognitive impairment showed 10 to 30% greater atrophy in two regions of the hippocampus than those who are cognitively healthy. The hippocampus is a key component in long-term memory storage. The atrophy starts in the commuomonis region and spreads to the subiculum. The brain of those with Alzheimer's showed even greater atrophy of the subiculum region, which helps explain why the disease had such crippling effects on the mental processes of those afflicted. As Alzheimer's progresses, the ventricles, the fluid-filled spaces in the brain, get larger, an indication of decreasing brain mass. Also, there are fewer nerve cells and synapses, though the cause of this death is not clear. It is suspected that a buildup of plaque formations between nerve cells may be to blame. Plaques are protein fragments made up of beta amyloid, which comes from the surrounding fatty nerve membrane. The plaques may block signaling between nerve cells, causing cell death, or by triggering an immune response in the area. Tangles are dead nerve cells that have bunched up and become entangled with other protein strands. This bunching may destroy transport of nutrients and oxygen in the brain, causing further cell death. The first areas where excessive cell death is noticeable are the regions of the brain concerned with learning and memory, as well as those for thinking and planning. The causes of Alzheimer's are not absolutely certain. Scientists have linked the disease to mutations in genes, such as the ones coding for the protein beta amyloid. However, there is also a significant amount of evidence that points to environment being crucially important to its development as well. Treatment options for those diagnosed with Alzheimer's are fairly limited, and mostly focus on behavioral treatments to help patients learn to do things on their own again. A lot of research has been focused on early detection methods because treatment is not begun until the disease becomes noticeable and it's almost impossible to reverse the damage. Recently, scientists in Japan discovered that the presence of the peptide APL1 beta 28 in the cerebrospinal fluid correlates with increased A beta 42 production. A beta 42 is a protein that is central to plaque formation. This peptide can be detected much earlier than Alzheimer's is diagnosed, so it would allow intervention to begin before serious and irreversible damage had already occurred. It is being considered the biomarker researchers have long been looking for in dealing with this disease. Other new research includes neuroimaging done with a new type of scan, a PIB-PET. It is able to show plaques in the brain that before were only visible after an autopsy. These scans have been used to show that plaque formation plateaus relatively early in the disease and therefore must be targeted earlier, since drugs that clear them later seem to be ineffective. A study done involving dogs, which showed similar degeneration to humans, used a vaccine with beta amyloid 142 protein to stimulate production of antibodies against the plaque-forming proteins. And despite the protein's removal from the key areas in the brain, cognition did not improve and the damaged neurons still remained. It has been agreed upon that the best way to reverse or treat the disease would be to repair or regenerate the damaged neurons. As the baby boom population in the United States ages, this disease will affect more and more Americans. Research done in this field is critically important because not only does the disease lead to a decreased quality of life for the sufferer, including personality change and depression, it also costs the family and the healthcare system millions to finance their care. Every day, science gives us hope and gets us closer to a brighter tomorrow.